I'll kind of describe what I've got set up here in front of the camera. This right here is a MotionMind 3 prototype, and it's going to be a replacement for a MotionMind 2. The only real difference is that it's RoHS compliant, which is a lead-free and other hazardous chemical-free build. Got a test board here that allows easier connections. This is a DC motor, and its shaft is connected to a potentiometer that's providing an analog signal as the feedback. Over here, we've got another potentiometer that's the control signal. And so, as I move the control signal, you can see that the motor's moving the potentiometer on the other side of the board, and that's doing the closed loop control. You can also see that as we move the motor abruptly, we're having some slowness to respond. And that's because the PID is not tuned in the MotionMind, so we'll make some modifications to the PID settings here in just a minute. Okay, so here we've got the MotionMind control software that you can download from our website. And I know that by the time this gets converted into a YouTube video, it's not going to be very legible. So I'm going to kind of describe what it is we're doing. Basically, what we need to do is adjust the proportional term, and we're going to make it larger. But before that, there's the PID scaler, which is a value that determines how large the output from the PID is going to be. And since we're using the analog feedback signal, we're limited to a feedback value between 0 and 1023 from the 10-bit A to D. And that's not really enough to get a good error signal when you have small errors. So we're going to adjust the PID scaler from the default setting of 14 to the default or to a new setting of 12. I'm clicking the check to store in EEPROM here and pressing the update button, and so that's going to make that modification. We'll go up to the P term, and we're going to make the P term, right now it's set at 6,000, which is the default, and we're going to move it up to about 15,000 to start with. And you don't have to get it exactly on. The slide bar will kind of get you in the ballpark, and we'll be doing a little bit of changes just to see how it kind of works out. Okay, so we're going to update that, and now we're going to go back and take a look at the changes in the functionality and performance of the motor. And so we'll have kind of some choppy control. You can see how it's kind of being overdriven there. You can see the jitteriness of it. If I give it a good jerk, well, it'll actually go under, or it'll lose its stability here if I give it a good quick change on the control. So we need to find a way to get rid of that so we can have better control of the device. But right now it's basically just a proportional controller with the proportional setting too high. So now we've increased the derivative factor, and what that's going to do is act as kind of a drag on the output, the PWM output that's driving the motor. So we'll have pretty good responsiveness. So you can see whenever I move the controller here, we're getting a fairly smooth control in the output, and you can still see there's a little bit of jitter there, and a fast turn will probably give us a little bit of, there we go. So we lost a little bit of that stability there. When I'm grabbing the load, I'm just kind of making sure that it can't overdrive itself, and that gives it a chance to settle back down. So now we've turned the proportional gain back down, and we've increased the integral a little bit, and we've got good control. Fast turns aren't causing it to go out of control and lose stability. So this is a kind of where you might start thinking you've got it tuned and ready to use as an analog feedback control system. So now you can see that I've taken the motor and disconnected it from the analog feedback, and I've taken the quadrature encoder, also called an incremental encoder, and connected it into the test board. That's essentially wired through a set of spring-loaded test points up into the MotionMind 3 prototype. And I've gone into the communication system and set the encoder feedback bit in the function register. That means we're now operating an analog control. with an analog input signal of 0 to 5 volts, and the feedback is now coming from the encoder as opposed to the analog potentiometer feedback. So you can see that as we move it here, we've got control of the system. So that's one of the features you can kind of modify to use a different kind of a feedback system, which makes the product a lot more versatile.